All right, let's get started with AWS. Well, even before we get started with AWS, we gotta understand certain fundamentals of networks. So we'll start with network fundamentals. Why? Why do we need to know about networks when you're doing AWS? Well, regardless of where your infrastructure is built, on premise or in the cloud, you will have um, networks for sure, because even in cloud you have racks, servers, firewalls, cables, right? IP addresses, IPv6, IPv4. These things haven't changed at all. The way we are computing as end users has changed. Now we are not buying any servers. We are just hosting our infrastructure in servers, which we do not own. That's all. But if you look at cloud computing infrastructure providers, well, they do have servers in the backend. And then to transmit data from one point to another, you will need networks for sure. Even in the cloud, regardless whether it is AWS, Azure, or Google, you will need to first create your own private isolated network. Such private isolated networks are called as VPCs in AWS, right? The first private network is called as a VPC, also called as Virtual Private Cloud. This is equivalent to networks or creating your data center. Private isolated data center in the cloud is called as a VPC. Within a network, what you have is multiple subnets. These terms are new to you, like subnets, classes of IP addresses, gateways, CIDR block. These terms may be new to you because you're primarily from the database background. So let's take a step back, and instead of talking about VPC, let's talk about networks here. I'll just brief you about classes of IP addresses, which you may already know because of the level of experiences that you carry here. There are different classes of IP addresses, primarily defined in an RFC called RFC 1918. And that says that the private class range is categorized as Class A, Class B, and Class C. There are other classes as well, which are called as Class D and Class E as well. Class A IP addresses start with 10.x.x.x range. Class B IP addresses start with 172. Class C IP addresses start with 192 series. These are private IP addresses. What is a private IP address? A private IP address is something that exists within your local LAN, is privately routable. It's not routable on the internet. It's not routable on the internet space in the public area. What are public IP addresses? Public IP addresses are routable on the internet. Anything that is not in RFC 1918 is public IP. All right. So whenever you design your private cloud or private data centers, you ensure that your IP addresses are in one of these three spaces. Class D and Class E are not used in today's world. They are used, but only for research purposes. Nobody uses it for corporate networks or even in your uh, home network. So if you do Windows R command prompt, yeah, and then I do ipconfig on my computer, I get my IP address. Now this IP address is given to me by my DHCP, by my router. 192.168.1.3 is the IP address which is given to me. This is class A, B, or C. This is clearly class C, right? 192.168. Apart from that, there is another special IP address which is called as a Pipa, Automatic Private Addressing Scheme. Any IP that starts with 169.254.x.x, these are called as a Pipa IP addresses. That means when a computer does not get an IP address, it gets an IP and it actually assigns an IP to itself. How does IP addressing happen? IP addressing happen through a process called as DORA, right? That's how DHCP works. What is DHCP? DHCP stands for Dynamic Host Configuration Protocol. What does that mean? Well, DHCP server or a DHCP module is supposed to lease IP addresses to the client machines or client devices. Like when you reach your home every day, your mobile phone automatically gets connected to the wireless router. Because authentication happens, your credentials are saved in there already. Authentication happens. Basically, when you power on the laptop in your office, along with you, there are hundreds of other people who power on their laptops, isn't it? And desktops, and servers, and several other devices. When you start them, the server or your laptop or computer shouts on the network. Just shouts. When we say shouts, it means broadcasts. It broadcasts on the network and says, hey, somebody give me an IP address. It says, give me an IP. Somebody give me an IP. The only guy who responds to such a packet is a DHCP server. Rest of them cannot do anything about it. When we say broadcast or when we say shouting, it means everybody is listening to it. You're not telling it silently to one person, right? When you say broadcast, it's like a radio. Everybody listens to it. But can somebody do something about it? No. Because if the radio guy or the radio jockey says that, hey, there's some kind of a help somebody needs in some corner of the city, anybody who goes there much appreciated. Not everybody will go there because of their own situation. Only guy who will go is somebody who's close to it or somebody who wants to do that kind of help. So broadcasting doesn't necessarily mean that everyone will take action, but everybody will for sure listen to it. But only guy who can do it will absorb it. The guys who cannot do anything about it will drop the packet. Similarly, the client machine broadcasts and says that, hey, give me an IP. There are other devices like other computers, other servers, printers, cameras, everything that's there on the network listens to the packet and drops the back packet because they cannot do anything about it. They cannot give IP addresses. The only server who can give IP addresses is the DHCP server. So this broadcast is complete. And this part is called as discovery phase, where the client machine is trying to identify the DHCP server. The next one, now that the DHCP server has found a person or a machine, or the client machine has found a DHCP server, the DHCP server offers an IP address. It just offers an IP address to the client machine. Hey, you're shouting and saying that you need an IP. Okay, take an IP, right? Now this part is called as offer. Next one, the client machine now says that, oh, okay, I've been shouting on the network. It says, thank you very much, because you gave me an IP. But then make sure that you do not give this IP to anybody else, right? Hence, keep it in your memory. Keep this in your memory. Or map my IP to my MAC address. This is called as request. The DHCP server says, okay, great, I'll do that. I will map your IP to MAC address, but I cannot do that forever, right? I cannot just keep your IP address and the MAC address forever. I will lease it to you. And here's the lease period. Usually the lease period is like 3 days. At your home, it is 24 hours. In enterprises, it is 3 days, 7 days, yeah, not more than that. Right? So this part is called as acknowledgement phase. Now this is how DHCP works. Discover, offer, request, acknowledgement. So the client machine gets an IP address for a specific duration of time, not forever. You can check the duration by just doing ipconfig/all. And if you look at it, I got an IP address of 192.168.1.3. My lease, I got it at 7:50 p.m. on Jan 3rd. That means this computer has been on since yesterday. And this expires on whatever time, whatever date. This is basically more than 24 hours. So my lease period is 48 hours in this case. All right. So that's how DHCP works. In cloud environment, we don't have to worry about DHCP, because as soon as a server is provisioned in the cloud, it automatically gets an IP address. That means you are not responsible for DHCP server. You're not responsible for that at all. Okay. Now, moving on, we also have to talk about something called CIDR block. This is very important because we'll be using this term a lot when we'll be building networks in the cloud. Let's try to understand that with picture. Here we will be converting numbers like this numbers like this. These are decimals, right? 192.160, these are decimals. We know that computers talk in terms of numbers, but not decimals. They only know zeros and ones. They only know binaries, not decimals like this. Decimals is for us, for people like us who do not understand zeros and ones. Computers are very good at zeros and ones. So let's try to understand networks the way computers understand. Now, in this picture here, I'll draw two devices. One is a device A, that's one laptop, and this is another device called device B, That is your laptop. There are two devices, device A and device B. Now, let's just imagine that they got an IP address from the DHCP server, right? They shouted on the network, they completed the DORA process, and they got an IP address called 192.168.30.5. And there's another device B that also got an IP address of 192.168.30.20, let's say. If you look at this, the computers get an IP address, but they don't stop there. They also get a subnet mask, right? Now, in this discussion, we will understand the importance of subnet mask, importance of firewalls, how do you write rules on the firewall, and how will you handle firewall rules if there are hundreds of devices. That's the crux of this discussion. You may be thinking that why are we talking about this in an AWS course? Well, it's really important because you'll see a lot of documents and videos and out there, and even on Udemy, on Linux Academy as well. People do not talk about the importance of CyberBlock block at all. People will just say, hey, create a VPC and put the CyberBlock block as 192.168.0.0/24. That's all. It is deemed and then assumed that somebody who's attending a cloud class knows what a CyberBlock block is. But then I don't go with that assumption. It is really important for the capacity planning purposes. So when a customer says, hey, create a network that can host only 15 devices, I don't want anything bigger. Create a network with 15 devices. Another customer says, make sure that my network can host 24,000 devices. Then how will your CyberBlock block vary? Right? So this is mostly used for capacity planning purposes, and CyberBlock block decides how many devices you can have in that network. So please be patient with me. We will be starting AWS soon, but then if your fundamentals are strong, you will be confident. Now the subnet mask 255.255.255.0, and the subnet mask here as well, 255.255.255.0. All right. Now these are decimal numbers, and like I was saying, that it's important to have these numbers converted to binaries, because computers don't understand these 192s and 168s. They only understand ones and zeros. So let's go split up these numbers to binaries. How do you do that? Well, school mathematics, right? 192 convert to binary. How do you do that? Just split up by 2. 192. And then if you divide by 2, what do you get? 2 9s 18, 2 8s 16, 2 8s 96, right? No, 28. All right, and once you do that, you get remainder as 0, correct? There's nothing remaining there. Then this one, 2 4s 8, 2 8 16, again nothing is remaining. 2 2s 4, 2 4s 8, nothing. 2 12s, nothing remaining. 2 6, and then nothing remaining. 2 3s, and say nothing remaining. 2 1s, and then finally 1 is the remainder. Now that you got ones and zeros, what you have to do is now write it in reverse order, like that. Now what do I get? I get 1 1 0 0 0 0 0, another 0. Yep. Okay. Any questions so far? Any questions so far, team? Ramesh, Prasad, Manny, Kiran, Evo.
No.
Oh. Okay. If you got no questions for me, let's do this for 168. You got a pen and paper next to you? Go ahead and do it for 168 and let me know. Put that in the chat, so I'll put it here. One 168, please. Get it? Convert the 168 to binary. Great. Well, I got one answer. You can just use a simple calculator now to do that. So this standard scientific, no, programmer, yeah. So 168, 10101000. That's right. And then paste that. Next one, 30. 30 will be that. 11. There's 4 ones. 000. And then 5 will be 0000101. Okay. I think the font is too small, so I'll increase the font. Okay. Let's do the same thing for 255. 55 is all ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Oh, this will be 0. 0 is all zeros, right? 0 is all zeros. Now, happy so far? All good? You will see that there are 8 placeholders here. 2 of them are on bits, rest of them are off bits. On bit, off bit, on bit, off bit. If you count all of them, we got 32 bits, right? Equal to 32 bits. So that's why IPv4 is called as a 32-bit IP addressing scheme. IPv4 is 32-bit IP addressing scheme. IPv6 is 128 bits because it has both alphabets and numbers like this. Look at this. This is an IPv6 representation. Now, what's the purpose of converting this decimal to binaries? Because we want to conclude something, right? To conclude, we have to do certain operation here, and that operation is called as AND operation. In our college, we might have heard about this AND, OR, NOR, right? So let's do an AND operation between the IP address and subnet mask. How does an AND gate look like? It looks like this. Let me see if I can draw something. That's, and then that's how AND gate looks like. Then that is the output, and here is the input. Looks like more like OR, but if we just Google around, AND gate, yeah, look at that. That's an AND gate, right? That's an AND gate. So if the input to A is 0, input to B is 0, the output will be 0. Input to A is 1 and input to B is also 1, then output will be 1. Input to A is 0 and input to B is 1, then output is 0. So basically multiplying. It's multiplication, right? 0 and 0, 0. 1 and 1, 1. 0 and 1, 0. 1 and 0, 0. It's multiplication. That's exactly what we're going to do with this guy. 1 and 1, 1. 1 and 1, 1. 0 and 0, 0 and 1, 0. 0, 0, 0, 0, 0. Dot. 1 0 1 0 1 0 0 0 dot 0 0 0 1 1 1 1 0 dot 0 0 0 0 0 0 0. Right? Is it clear?
Yes.
Okay, great. Now this is for device A. If you do the same thing for device B, now I'm not going to do so much of hard work again because half of the work is already done. 192.168.30, this part is already done, right? This part is done. This whole part is done. For 20, if you convert decimal to binary, you'll get some value, right? Well, let's not do that hard work again. Let's put that value as y, because y multiplied by this 0 is again 0. That also tells me that regardless of what value I have here, 192.168.30.5, 6, 20, 200, 120, whatever value I put, the output of these two will be same because the subnet mask is same. The moment the subnet mask changes, the output will be different, isn't it? So if the subnet mask is 255 or 255 or 254.0, this will change. It will become this, and hence the output will change, right? What this tells me is that when the subnet masks are different, outputs are different. What does that tell the computer? It tells the computer that when two devices talk to each other, when device A has to talk to device B, this guy has to talk to this guy, right? They have to talk to each other. Then they calculate the subnet mask values. If the outputs are same, they decide that they are in the same network. If the outputs are different, then they decide that they are in a different network. So if the subnet mask over here changes, subnet mask over here changes to 255.255.252.0, then the output will be different. And when the output is different, machine A and machine B are not in the same network. So subnet mask decides the network. Subnet mask tells that, hey, you belong to same network or a different network. When they are in the same network, then at your home you got two devices. One is your laptop, another is maybe another laptop or another mobile phone. If both of these computers have to talk to each other, they will use the router, right? They'll use the router. That's the antenna. They'll use a router to talk to each other. But you know what? When they're in the same network, they can talk to each other directly like this. They do not need to go through the router because it is a gateway. It's a gateway. The default router is called as a gateway. Gateway for what? Gateway to send the traffic out of your network. So there are two different rooms, and if I'm sitting in your room, the same room as you are, then you can just turn around and talk to me. But if I'm in a different room, then you have to walk out of the door and then get into the door of another room and then talk to the person. Similarly here, in this network, when machine A and machine B are in the same room or in the same network, they do not have to go out of the door at all. They do not have to go out of the door because they are in the same room. But the moment machine B is found to be in a different network, then it has to contact the default gateway. Default gateway is used only to send and receive the traffic from different networks. Okay, let's move forward. All right.
So now it's the same network, right? Because the outputs are same.
Outputs are same, then they're in the same network.
Same network. Okay.
Yeah. Now you're sitting in your office. This is your laptop. On the right side is the timesheet server. Every day you come to your office and then fill up the timesheet, and you do http://timesheet, and that works great. Every day you fill it out. One day the auditing team or the network security audit team comes up and does an audit. Audit is done, the results are released, and they say that, hey, this timesheet is vulnerable. People can directly get into the database and then start playing around with that. Why don't you put a firewall? Well, after discussion and the change management processes, a firewall is set up. Right after that, nobody in the network on the left side is able to fill up the timesheet. Why? Because firewall has an explicit deny. That's how firewall looks like, isn't it? Firewall is an explicit deny. It doesn't let anybody do anything. That's the default behavior of a firewall. So now you stand up, walk up to the network guy, right from here, you walk up there and say, hey, I'm not able to fill up the timesheet. Well, the network guy says, hey, I can't do nothing about it because there's a firewall. You go ahead and create a change request. So in your ITSM portal in ServiceNow or whatever tool you're using for ITSM, you will go ahead and create a ticket for the network guy. Network guy then opens up the rules for your machine, right? How do you write the rule in the firewall? You write the rule as follows. You write the source from where the port needs to be opened. You write the destination, write the port number, then the protocol, then status, whether you want it to be allowed or denied, and then finally some remarks that you may want. Remarks like who requested for that, when was it requested, what's the change request number, etc. The source is 192.168.192.168 dot whatever 30.5. Destination is 192.168.30.20. Port number 80. Protocol TCP. Status allow. Remarks is my change management CH request for change 34, 56, 23, 90, and whoever requested for it, etc. Right? Okay. Good. Problem solved. But another problem started. What if you are not the only guy who's filling up timesheets? There are 20 other devices like that. There are multiple devices like this who are filling up the timesheet. You're not the only one. Hundreds of other devices are there. Right? When there are hundreds of devices like that, you may just say, hey, why don't we go ahead and write the rule 100 times for each of these IP addresses? 192.168.30.5, 30.6, 30.7, 30.8. Let's write it for them. Good. Yeah, that will solve the problem, but temporarily, not permanently, because these devices, A, B, C, D, all of these devices, they get an IP address only for certain duration of time. Remember the lease period? They don't get the IP address forever. Their IP address change. And when the IP address changes, it doesn't go and automatically reflect in the firewall. And the moment IP address changes, he will not be able to fill up the timesheet. Isn't it? Then our solution just fails. The solution to put the IP address manually in the firewall rules. We don't want to do that. We have to write a rule in such a way that it is dynamic. It accepts the entire range of machines. Today we have 4 devices. Tomorrow we may have 20. In about 1 year we may have 200. Right? It must be dynamic. We don't want to allocate just one network engineer typing in the firewall rules every day from 9 to 5. Not his job. Let him do once, and let that rule accept whatever gets into your network. Right? So you have to then define the entire network in one single notation. One single notation. Such notation is called as CIDR notation. CIDR notation represents the entire network, all the devices in your network, right? Now, I will park CIDR notation for a minute and then go back to initial point, this particular point, right? We'll go back and talk about it and then come back to CIDR notation. I've parked the CIDR notation for a minute, exactly for a minute or two, and then we'll come back to the parking lot to drive the CIDR notation. Now, I've got 192.168.30.5. The subnet mask is 255.255.255.0. Let me just tell you, what does that mean? It means that I've got 8 plus 8 plus 8. 24 bits on. It also means that 24 bits are masked. 24 bits are masked. When I say 24 bits are masked, that means these, where is it here? These set of IP addresses, they never change. Or this 192.168.30 in that network never changes. But the last octet, remember it's called as an octet, the last octet changes because it's got a 0 in it. When you have ones, it never changes. Once you have 0, it changes. That means that in the entire network, 192.168.30 never changes, and hence that part is called as network ID, right? So an IP address constitutes of 2 parts. One is a network ID, which is a constant, and a host ID, which is a variable and keeps on changing, right? It is unique. So network ID is 192. Okay, 192.168.30 is network ID, and the last part is a variable that is not unique. Sorry, that is unique in every machine. Every device has a unique host ID. Now, in order to calculate a CIDR block, we will need this help. We'll need help of this particular knowledge. But it may also change if your subnet mask changes. Let's say your IP address is 192. Maybe change the class A 10.20.0.0, and the subnet mask is 255.255.0.0, right? Then in that case, your network ID will be 10.20, and the host ID will be the remaining bits 0.0. That's your host ID. So how many hosts can you ever have in this network? 192.168.30.0. This part is 192.168. 30.5 and the subnet mask is 255.255.255.0, how many hosts can you have? Well, your IP address here will start from 192.168.30.0, 30.1, 30.2, all the way till 30.255. Right? So how many IP addresses can you have? Say 30.0, 30.1, 30.2, 30.3, all the way till 30.255. So in total, it seems that we can have 256 IP addresses, 0 to 255, 256 IP addresses, right? But 0 and 255 are not assigned to any device. For example, 192.168.30.0 is not assigned to any device because that is used by the network. And 192.168.30.255 is also not assigned to any device because that is used for broadcasting purposes in the network. Hence, we'll have 256 minus 2, which is equal to 254 IP addresses. Right? In total, we'll have 254 IP addresses when the subnet mask is 255.255.255.0. Does it make sense?
Yes.
Yes.
Yeah. Ramesh? Kiran? Prasad? Okay. All right. So when we look at CIDR notation here, the CIDR block, we have to first write the network ID. The network ID in my case is 192.168.30 and say .0/24. That is the CIDR notation. How did we come up to this particular number? I first write my network ID and then a 0 because that's a variable /24. What is 24? 24 is the number of ones I have in the subnet mask. 8 plus 8 plus 8. I got 4 octets. First octet, second octet, third octet, fourth octet. I've got 24 ones and hence I'm writing 24 here. So when you write this piece, when you write this part on a piece of paper and give it to a network guy, he will understand several things. Just imagine that you got written this on a piece of paper and you walk up to the network guy and then say that here's my CIDR notation. He will understand several things. Number one, that 192.168.30 is the network ID, right? Then my subnet mask has 24 ones, and hence my subnet mask will be 255.255.255.0. Third, how many hosts do I have? Since 192.168.30 is the network ID, just the last part is remaining, and that is the host ID, and hence it will start from 192.168.30.0, 30.1, 30.2, 30.3, 30.4, 30.5, and it will go all the way up to 30.255. But then I cannot use 0 and 255, so it will be 256 minus 2, it will be 254. Hence the total number of devices that I can host in /24 network is equal to 254. Is that clear? And hence my firewall rules for this will change. It will be 192.168.30.0/24, and then the destination is 192.168.30. Whatever, 30.20, port number 80, TCP, allow, RFC number. Okay, If you're clear, we'll move ahead with AWS VPC. We'll go ahead and build certain networks in VPC. All good? Okay. So let's go ahead and build our first network. Always before building something, gotta make some diagrams here. So what we're gonna do is this will be our first network, and let's say the CIDR block of this network is 192.168.0.0/16. I'm gonna use /16 here, and if you calculate right, /16 can host approximately 65,000 hosts. So 192.168.0.0/16 can host approximately 65,000 devices, right? Let's just imagine that. No, this is the four walls of your network, four walls of your office, and within these four walls, you may want to set up your office, maybe 30-seater or 40-seater, maybe 400-seater or something. There are certain situations where you do not want certain networks to talk to another set of networks, right? Within this network, you want to create smaller networks, which is network 1, and then network 2, and then network 3, and network 4, and so on. And then within this isolated network, which I'm calling as VPC in AWS, what I want is I want isolated networks within my isolated network. So this will be one subnet 1, and this one will be subnet 2. So this is an isolated VPC. That means nobody can get into this network at all. Nobody can get inside this network. The only person who can get into the network is the one who is allowed to do so, which we'll see how you set it up. So this is your isolated VPC. Within this, you have created two different subnets. Now, by default, devices, these are devices, machine 1, machine 2, machine 3, machine 4, machine 5, machine 6, etc., etc. By default, subnet 1 does not talk to subnet 2 and vice versa. The devices in subnet 1 do not talk to devices in subnet 2. That is for complete isolation. So you have created isolation of networks, and yeah, so this is a good use case for let's say you got multiple clients, right, in your office, in your like 5,000-seater office. You got multiple clients, and this subnet 1 belongs to healthcare client, and this subnet 2 belongs to banking client, and banking client does not want the devices in the banking subnet to talk to other devices, and vice versa, right? So you're creating isolated networks within the VPC, right? So consider this as your home itself, your small office, home office network, where you got a wireless device, and then you can create multiple subnets inside it. So this is more like a VLAN approach, virtual LAN approach. All right. Now, if the traffic really has to go in and out of this network, you need to have something called as a gateway, right? Without a gateway, traffic cannot get in or get out. Hence, you need a gateway. This is also called as an internet gateway in AWS, right? This internet gateway has to be attached to the VPC, and then in order to allow the traffic in the internet gateway, you have to write the routes as to who should be allowed. Because if this network is exposed to the internet, everybody can get in. If this network is exposed to only certain IP addresses, only they can get in, right? So this is how you create a VPC. Let's write the step-by-step process here. Number one, how to create a VPC. You first create a VPC and assign a CIDR block to it, just like the way you did here. Right? Create a VPC, assign a CIDR block. Second, create subnets, and then assign CIDR blocks to the subnets as well. These subnets, subnet 1 and subnet 2, also have CIDR blocks, right? Like 192.168.30.0/24, and this one will be 192.168.40.0/24, let's say, right? So devices in this subnet 1 will have the IP addresses in this range, which is 192.168.30.1, 30.2, 30.3, 30.4, etc. Whereas in subnet 2, you will have the IP address of the range 192.168.40.1, 40.2, 40.3, 40.4, etc. And they do not talk to each other. By default, they do not talk to each other. It's in your control whether you want them to talk to each other or not, but by default, they don't. Next. What is the next step? The next step is to create internet gateway and then attach the internet gateway to VPC. Fourth, you want to allow certain traffic in and out of your gateway, so you will write routes in internet gateway, right? So once you have written the routes, people from the internet will be able to talk to your gateway like that. People only from those IP addresses. You have any questions for me on this one?
No.
Okay, yeah. There was some background noise, so I muted myself. Okay, thank you. So this is the AWS console here. We have a whole lot of services. It's categorized in compute, management tools, mobile services. Are categorized in several ways here. Initially, when I started, we had hardly one page of services, but now we got three, which is good in a way because Amazon is innovating and bringing in new services. So if you look at VPC, yeah, this is where you create your isolated networks. But if you cannot find it, there's a search box. Just type VPC here, and then click on it. Right now, on the top right-hand side, you will see the list of regions. So Amazon has data centers in the following regions. You got 4 in Europe, 1 in South America, 4 in United States, and a couple of them in Asia Pacific and Canada, right? So when I'm selecting a particular region, it means that I'm creating a VPC in that region. So I've selected US East 1. That means that I will be hosting my data center, isolated data center in North Virginia. If I click on VPC here, there is one VPC by default in every region. Look at this, default VPC, yes. Every region has a default network. So if I go to some other region randomly, clicked on Ireland, it will have its own network. Okay, there are 2 because I created one maybe sometimes, but this one is default, right? Every region has a default VPC. Let's go back to somewhere in US. Okay, yeah, so this is the default VPC, default yes, right? So let's create a VPC. I'll click on create VPC, give this a name, like I don't know, just like we have to follow certain naming standards that the company has. So I'll say VPC underscore network or something, and the CIDR block is 192.168.0.0/16. Do you want to give IPv6 addresses? Well, I don't want to give IPv6 addresses. If you want, then you can then just say Amazon provided IPv6. So the devices that are hosted in your network will then start getting IPv6 addresses, right? Tenancy, that is correct, Manny. AWS creates the default VPC for you when you create your account. You do not have to create the VPC by default. It's there. You can use it as well if you like, or I'll just cancel this. Now the CIDR block that is assigned is 172 class B, right? 172.30.100.16 is a class B. And if you want any other classes apart from that, then that's when I'll create my own VPC. Or you want a different CIDR block, then you'll use your own VPC with different settings. Okay, create VPC, name, say VPC underscore network, and my CIDR block is 192.168.0.0/16. Tenancy is default or dedicated. What does that mean? It means that if you want the resources like this, server 1, server 2, server 3, server 4, if you want them to be virtual, you select multi-tenancy. You select default. If you want them to be physical, if you want these machines to be physical machines, that's when you select dedicated, right? In this case, I'll select default. Default is for multi-tenancy, virtualization, whereas dedicated means a physical box, no virtualization. So I've created my first VPC. Then I'll go to the subnet section. I'm just following this step by step. Create a VPC, assign a CIDR block. Then I'm creating a subnet. Look at this, we got 3 subnets already here. That means these 3 subnets belongs to the default VPC, right? Yeah, default subnet. Yes. So these are, we'll just create this subnet and call it as subnet underscore network 1. In which VPC do you want it? I want to put that in my VPC. This will change accordingly. And then my CIDR block is 192.168.30.0/24. Remember, we were talking about availability zone. Looks like Ohio has 3 availability zones. In which AZ do you want to put that in? I'll select that and say create. Yesterday we were talking about AZ, or availability zone. These are uh, data centers within Ohio, which are geographically apart, miles away. And this one is subnet to underscore network, and I want to put that in my VPC. Select a different availability zone, and then this one will be in 192.168.40.0/24. Create. Okay, Manny, what is the advantage of the default and dedicated tenancy? Well, if you select default, right, when you're creating a virtual machine, at that time, it's going to create as a virtual machine if you're selecting default. If you select dedicated, then it will create as a physical machine if you select dedicated. That's the only difference. Okay, thank you. Now that your two subnets are created, let's go and create an internet gateway. So I'll click on internet gateway and then create internet gateway. Type the name as IGW underscore network or something. Create it. Now then you have to right click and attach to your VPC. In the drop down, select your VPC and click on attach. Then finally you have to write the routes or edit the routes. You might have noticed it does not say create routes. Create VPC, create subnets, create internet gateway, but do not create routes. A route will be created for you already by default, and this, look at this, VPC underscore network. This is your route. You have to click on it, routes, and then edit it to add a route. Where do you want the traffic to enter from? If you type 0.0.0.0/0, that means anybody can enter. It's more like a web traffic. 0.0.0.0.0/0 means it is internet. Anybody can enter. But if I want traffic to originate only from my IP address, I will put my public IP address here. Right? So in that case, only you can, or only I can enter. If my client says, if my client over here says, hey, nobody should be able to access my devices, only I should be able to access the devices, then you get his public IP. The client, hey, give me my public IP. The client then gives the public IP and says, hey, my public IP is 43.89.201.45/32. That's my public IP. So you take this and put that in the route here, right? But in my case, I'll do 0.0.0.0/0. And from here, I want to have access till my network gateway, and then save it. We created our first VPC. Any questions you have for me so far? Manny, Ibo, Kiran, Ramesh, Prasad. Okay, I've got a question. When you create your VPC and attach, does it when you create your VPC and attach, does it automatically disconnect the first one AWS created for you? Okay, so all right. this network that we created has its own internet gateway. If you look at this, I've got two internet gateways. This is 1 and 2. This one is attached. We don't need this. I'll just delete this. Okay. So every network has its own gateway. This gateway is for one network. This gateway is for the default network. Look at this. This is 9BB, right? VPC D2FA09BB. And 09BB is the default network. And this one, 538, is a different network. There are two different networks. They are isolated, two different networks, and both of them have their own gateway. They don't talk to each other. Two VPCs do not talk to each other. They are isolated. They have their own routes. They have their own subnets. They have their own gateways. So these two subnets that we created are in our network, whereas these three, 1, 2, 3, these are in the default network that AWS created for us. Okay. Right. So it's always recommended not to do the labs with me while I'm doing. It's always recommended that you watch. So if you do as I explain things and as I show it on the screen, then you'll be lost for sure. It happens. So it's very important that you go ahead and just listen to the tutorial or listen to the class, and then when you find time during the day or after the class, you do the labs, and that will be beneficial. Okay, so so first VPC is created. Let's make use of it. Let's go and create a virtual machine inside it. Okay, click on services, then always make it a habit to right click and open a new tab here, and then you see this empty space, this part, this box, click on it, it goes away. So that way I do not lose this section, right? The way I did it is click on services and then right click on whatever you want. Let's say right click and open a new tab and go back to this empty space and click on it. This is just a small trick out there. All right, so let's go and create an EC2 instance. EC2 stands for Elastic Compute Cloud, and this is where you create virtual machines. Services, EC2, right? And it's a summary, how many instances you have, volumes you have, how many snapshots you got, how many load balancers you got, etc. Well, let's go and create an instance. It just gives me a dashboard. I've got 3 availability zones, all of them are healthy, which is good. Got a lot of options on the left side. We'll go some of them in the upcoming classes. But let's go and create an instance. Wow, so when you click on launch an instance, it gives me like 1, 2, 3, 4, 5, 6, 7 steps right here, right? 7 steps to create an instance, and then a menu of operating systems. I've got a big menu of operating systems here. So do you want to create an Amazon Linux image, or do you want to create an Amazon Linux candidate AMI? It's got all of those binaries. Do you want to create a SUSE Linux? You want to create a Windows Microsoft, or what do you want to create, right? There's a whole lot of operating systems here. In your free trial, make sure that you select just the ones which have free trial tied up to this. So free trial, yeah, all these are good. Well, this is not eligible for free trial, it seems. This one as well. Anything that is in the bottommost section here, not eligible for free trial, right? Or if you want to take precautions here, don't want to, you want to click on them accidentally, you can check this box which says free tier only. So that means there is no scope of Amazon billing us, right? I'll check this. And in my case, I'll go ahead and select a Windows machine. So today I'm going to show a Windows machine. Tomorrow when we do load balancers, we'll see how to create a Linux machine also, right? So I'll select a Windows machine. Look at this, you might have noticed this already. Every image has a unique image ID, AMI-FE, AMI-69, etc. AMI, Linux. This is unique. This is unique. Every image has a unique image ID. Now, if I switch this from Ohio to North Virginia, and then look at this screen, the image ID for Amazon Linux AMI in North Virginia will not be the same as this. So within regions, even if you have the same image, same operating system, the AMI ID will be different, right? Why do we need AMI ID? So if you ever want to programmatically create, which we'll do moving forward in third week or something, second week, when you want to programmatically create instances, let's say you want to write a command, just write a command and double click on that command 20 times and 20 instances are created, right? You don't want to go to this GUI, graphical user interface, and create machines ever. So you can write a small script and say, create hyphen instance, hyphen instance ID, and this is an ID, and you put the hard code this image ID into your script. So instances with this image ID will then be created. Okay. And then it contains a description of what it has. Okay, so I'll have this one, Windows Server 2016 base, select. Now it gives us the computational requirements of it for your machine. The only one that is free is T2 micro. What does that mean? T2 micro means that your server will have 1 CPU and 1 GB of RAM. T2 small means that it will have 1 CPU and 2 GB of RAM, right? So you can also filter this like this. You can say filter them based on memory. So if your application is really memory hogging, it leaves a lot of memory, you can select that. And then let's see how much maximum memory you can get. The maximum memory that you're getting is about 2 terabytes. Just 2 terabytes of RAM, right? That's massive, right? Let's filter by all instances, then filter like this. Scroll down to the bottom. Okay, 488. Yeah, still 2 terabytes. Right? So this one is giving me like 1 CPU, 1 GB of RAM, which is good in our case. So I'm happy with that. Intel Xeon processor. Okay, EBS stands for Elastic Block Storage. We haven't discussed about that. We'll talk about it in a minute. How many instances do you want to create? 1, 2, 10, 20. You can just put the number there and it will create 20 machines for you in one go. Request spot instances. We will talk about it later after we are done with this, the upcoming sessions. Network, in which network do you want to put this? I'll select in my network, because remember we got two. One is the default, second is our custom made VPC. Within this VPC we got 2 subnets, and it asks, hey, in which subnet do you want to put this in? Subnet 1 or subnet 2? Based on that, accordingly it will get a private IP address, and it's got 251 IP address. Okay. Now, do you want it to get an IP address, a public IP? Private IP is something that it will get automatically, but do you want this machine to get a public IP as well? Well, you got 3 options. One is enable. It means that it will get a public IP. Disable. It means that it will not get a public IP. What is this third option? Use subnet setting. It means that it will pick up a setting from the subnet. Well, where is the setting in the subnet? We never noticed that there, right? Whatever setting you have in the subnet, auto-assign public IP address will pick up from there. But where is that setting? Let's go look at it. So we'll look at subnets. In subnets, it says auto-assign public IP no. Even for this subnet, it says auto-assign public IP no. So if I say right click and then modify auto-assign IP settings, now read this. It says that enable automatic assignment of public IP addresses to automatically request an IP address for instances launched into this subnet. That means all instances launched in this subnet will get a public IP if you check this box. If you don't check this box, they don't get a public IP, right? So I'll save it now, close it. All right, so Subnet underscore subnet 2 has auto assign public IPS, whereas subnet 1 has auto assign public IP no. Okay, we'll go back and I'll just refresh this. Select my network, select my subnet, and look at it, it's changed. Right? So these are the options that we have. Whether you want a public IP assignment or not is all up to you. Well, here, when I was explaining this, we split this subnets based on clients. We said healthcare client and a banking client. But it could also be a public subnet and a private subnet. That means that all the devices that are hosted in this subnet are exposed to the internet, and all the devices that are hosted in this subnet are not exposed to the internet because they are databases, right? So in that case, I will put the checkbox for the public subnet. For the private subnet, I will not put the checkbox. Amazon does not say anything about the best practices. They just say that here are the options that we have. Well, you want to use it, depending on the scenario. You want to keep everything private? Well, yeah, you can keep it private. Domain join IAM role is something that we'll talk later, because we haven't spoken about IAM at all, identity and access management. Okay, shutdown behavior. When you right click and shut down on the machine, do you want it to shut down or terminate? Enable termination protection. If you check this box, people cannot just right click and terminate, right? There will be additional set of actions that they have to do. So I'll show this to you. I'll put this checkbox now. Enable CloudWatch monitoring. What is CloudWatch? CloudWatch, if I click on services, there is something called as CloudWatch here. CloudWatch is for monitoring. You want to monitor your infrastructure? That's when you use CloudWatch. But it says enable CloudWatch detailed monitoring. Well, whether you enable CloudWatch monitoring or not, it will still monitor your infrastructure. For CPUs, network utilization, and all that, it will still monitor, right? But then if you put this checkbox, you get granular monitoring. You get more detailed monitoring. What does that mean? So if you look at monitoring graphs, they are time versus CPU, time versus networks, time versus disk IOPS, etc. The time interval here, if you do not check this box, will be 15 minutes. The time interval, if you check this box, will be 1 minute. That's the difference. If you check this box, there will be additional charges. Tenancy will be whether you want a virtual machine, which is shared. Do you want a dedicated machine, which is physical, or do you want to host a virtual machine on a dedicated machine which you already have? Right? That's what it means. So a virtual machine, shared, a physical machine, dedicated. Last one, dedicated host, is like launching this instance on your dedicated physical box. Anything else that you choose from? Like shared is free. Shared is free here, but if you choose anything else, you'll be charged. Do you want additional GPUs? So if you're building a gaming application or anything that needs higher graphic power, then that's when you use GPUs there. T2 unlimited, we'll talk about it later, just like the way we left IAM role, directory join role, etc. We'll talk about T2 unlimited later. Do you want to have additional network cards? You can choose there. Advanced details, where you can just put a startup script here. So when the machine is pulled up from the image, this startup script then gets executed. You can just put the startup script here and say, hey, install IIS or install whatever, you can install anything, install and copy the contents from a different directory to this machine, etc. It's more like a startup script. Next, you can add storage. Because it's a Windows machine, it's showing 30 GB of size and volume type. Three kinds here. One is magnetic. Magnetic is used for non-production purposes, something in the middle. Then you'll go for general purpose. General purpose is giving you 3000 IOPS per second, up to maximum. It's burstable up to 3000 IOPS per second. But if you select provisioned IOPS, it can burst up to 10,000 IOPS per second. So this is expensive and also not free. So in production, you use provisioned IOPS. It goes up to 10,000 IOPS. You can change this number here, right? So if you put your mouse on that I thing, it says the maximum IOPS that it can burst up to is 10,000, provided you put the maximum burstable load here. In this case, I'll select general purpose. Delete or termination. When you right click and delete the VM, do you want the hard disk to be deleted as well? Well, yeah, you put the checkbox there. Encrypted, do you want that to be encrypted? You can add multiple volumes over there. Add tags. Tag is just for your identification. Just put the name and then say web server. You can have multiple tags, say business unit. Business unit is apps team. Who's the business owner? Is apps team at company.com. So after like 20 days when you have created a lot of machines for different clients, you can pull up a report later on and say, hey, how many of these machines belong to apps team? And then later on you can do a chargeback against those units. Okay, so next. Now security group is nothing but a firewall. A security group is a firewall. This is where you allow rules. So in this case, it detected that it's a Windows machine and it's adding port number 3389 from internet. You can add your own rules and then say, hey, I want to make it a web server, and hence I'll add HTTP port number 80 from where? You have these options from anywhere, which is 00. From custom, you can put your own IP address, so traffic will be accessible only from that IP, or you can put my IP. So when I select my IP, it gives me that IP address, right? So I'll say custom and then say allow it from anywhere. That's 0. Say review and launch. Okay, now this is a summary section, and finally click on launch. Now remember, nowhere in this screen it asked for credentials. How will you log into this machine? What is a user ID? What is a password? Right now, Amazon does not use user IDs and passwords. They use keys called public keys and private keys. This is part of asymmetric encryption. Now, asymmetric encryption uses two different keys, a public key and a private key. A public key is something Amazon stores, a private key will be stored with you. When you want to get authenticated, you need to present the key to Amazon. You will have your key, you present it to Amazon, there will be a handshake between public key and a private key, and if they match, the password is given to you. If they don't match, then you will not get authenticated. So I'll select a new key pair, use some key pair, give it some name. I'll just give it some name and make sure that you download this. Download this key pair and then launch instances. Right, so my instance is launching. That is my unique ID that my instance has, I-0A whatever. That's my unique ID. Click on this. And it takes me to this section. So my PEM file is there. This is called as a PEM key or a private key, which is there with me. Now, this is in pending status. Give it like 4 to 7 minutes. The instance will be created. It has a public IP. It is launched in a subnet which has a CIDR block of 192.168.40.0/24. It is in the following VPC ID. So this is the metadata This is the metadata of that instance. Inbound rules, that's port number 803389, launched over time. So we can look at other details like this, scroll up and down, status checks. So it has to complete the status checks. Although it is up and running, it has to complete the status checks, status check 1, status checks 2. So by the end of it, it must say 2 by 2 complete, right? Monitoring, you can look at the statistics, CPU, disk, read, networks, etc. for troubleshooting purposes. Tags, all the tags, you can add later tags later on as well. Well, there are other options as well, which I would like you to explore. Say right click and then say instance state. You can stop, reboot, terminate instance state. Settings can be changed. Image can be changed. Network, you can change the security group. So go ahead and explore these options once you have created the instance. I'm just waiting for this to complete. And I'll pause for now just to ask if you have any questions for me so far. Anything?
No.
Thank you. Just waiting for that to complete it, and then we'll log into the machine to see how that goes. Has everybody created their AWS accounts? I know Ramesh answered that earlier, but
Yes.
that was quick, isn't it? It doesn't take much time. Yeah. Okay. All right. That's thanks, Kiran. That's created. Let's go. Let's go use this IP address. Let's see how that goes. Windows R MSTSC. Yes, there you go. The user ID. What's the user ID and password? Let me just gonna say right click and get Windows password. My key pair is Jan 2018. Get the file from somewhere. That's it should be in my downloads, which is what 2000 no, Jan 2018. So decrypt password. That's the password, right? Go back. Bam. Connected. Okay. Let's even try to make it a web server. So this guy is ready. I'm going to quickly make it a web server as well. I'm going to launch PowerShell. I'm just trying to make it a web server. So that way we can host some websites on that one. that one. Let's see. All right, looks like the web server is ready. All I have to do is just go to my browser and paste the public IP there. So what's my public IP? That's my public IP. Just copy and paste that in the browser. There you go, that works. That's my first website. It's ready, right? So you should be able to access that from your console. I'm gonna put the IP address there in the chat. And if I go ahead and modify this, like create a small file here, new file, name it as index.html, view file name extensions. All right. Now try to access this. There you go. That's ready. So congratulations, you learned how to build your first network and the first EC2 instance. Also, you made a web server. And this was working only because we opened port number 80 here. Remember? View inbound rules. We opened port number 80. Otherwise, it would not be working. All right, so done for my agenda for the day. Unless you got any questions for me.
So once we register from AWS, so we can do this. I can do this practice, right? This one.
Absolutely. Yeah, you got to have your account subscription created, and then that's when you'll be able to do these labs.
Okay, sure.
One last thing that I want to show you about terminating the instance. When I say right-click instance and say terminate, remember I put the checkbox which says protect from accidental termination. So this guy is grayed out. See?
Okay.
Yes, this is grayed out. So let's say right-click, and I'll change that setting, change termination protection, disable it, and then you try to delete it. Terminate. Termination kills the machine forever. You cannot get this machine back again, right?
Okay.
Any other questions from anybody? Please go ahead and do this lab. Create your own VPC, create the virtual machine, make it a web server. Yeah, initially it may take some time. If you do it a couple of times, it will be hands-on then.
So because he terminated the instance, once we try to access that IP on the web server, it's not gonna, what you just created is not gonna show up, right?
No, it's gone. It's gone.
Okay.
It's gone.
Okay. sent you an email earlier too, so when you get the chance, you can check.
Okay, sure. Okay, thanks everybody for your time. If you have any challenges, I'll just put my email address here. Yeah, when you're doing the labs, you got stuck up in any hiccups, just let me know. I'll be happy to answer that. I'm usually on my phone all the time, so you answer that immediately. Yeah, take care, guys. Yeah, thank you.
All right, thanks.
All right, thanks.
Thanks, Manny. Thanks, Karen.
Thank you.
Thanks, Prasad. Amesh, thank you. Bye.